Hey, Guillaume.
Hello, hi Bernd.
Hi, how are you?
Good, thank you.
Hi, folks.
Good morning, or hello.
Hey.
Everyone.
It's not morning.
Yeah. Yes. Good evening to Bernd and
Yes.
Guillaume. Guillaume, is that a chalkboard behind you?
Yes, my kids.
Oh, okay.
I'm sharing the office with my kids, so sometimes you can see weird things. They are learning English, actually.
Oh, nice.
So while people are joining, I'm actually trying to recall where we ended last time in terms of going through the comments. I think anyways, in between people added additional feedback, but maybe would be good to kind of start where we ended last time. I'm not entirely sure. I think we talked about the CRD topic. Maybe we didn't.
I'm trying to remember as well. Looking at some of the notes from the session 2 weeks ago too, down at the bottom of the doc.
I see you made a comment referring back to the April 21st session. Not sure if that means that that probably means we talked about it. That was on Guillaume's question around the Kubernetes API and if or if not, should be surfaced to developers. Hey, Chris. Hey, Simon.
Hey, Bert.
Hey.
Hi, all.
Let's still wait 1 or 2 more minutes for people to join. So I'm thinking, Eric, probably this is where we stopped, and then this is probably where we should continue. What do you think?
Yeah, that sounds good. Or go ahead, Guillaume.
Yes, maybe there was a thread end of page 2. I think you're beginning of page 3, I believe.
Mm-hmm. Yeah.
Yeah. Should prepare to, yes, indeed, should prepare to highlighting end of page 2. There was the thread about yes, what to surface for API developers. for application developers in terms of if they are in the personas where they are actually also using Kubernetes API, whether the Create Foundry for Kubernetes should aim to become a template engine into which the PaaS is creating objects and the user's resources, and the user has visibility into these resources, can see them, and what kind of backward compatibility contract is provided. Should they see pods, services, secrets, and so forth, or should it be restricted to more long-term contract, such as discoverability, maybe observability, and not that much on the actual Kubernetes resources backing the managed apps. So that was one thread. But yes, Eric, sorry, I didn't have time to see your comment from yesterday and today, so it might be a duplicate.
Let's maybe resume there, looking at the time. I know that at least Jens will join a little bit later, but probably should get started. So I'm not sure, Eric, do you want to like summarize the comments that you put in recently?
Yeah, I think a lot of the commentary on that section had happened before the call 2 weeks ago, and so I did want to sum up some of what we had discussed on the call on the thread, and then I didn't recall if we talked about this, but I think one hypothesis that we have is that if there's a relatively direct correspondence between a CF space and a namespace in a particular cluster, maybe let alone some of the discussions about spreading workloads in a space across multiple clusters. But if there's that kind of direct correspondence, that might make defining policies via K8s RBAC that allow that kind of restriction easier than having to do something more nuanced in terms of policy around object metadata with like OPA and Gatekeeper. You know, if it had to look at some label or annotation on the resources that said like, actually, this is in the CF space, so allow this set of users access to it, but not this set of users, that seems like pretty brittle. But if that is a simpler expression in terms of, okay, you know, there's this role or cluster role or something defined in the cluster that effectively corresponds to the space permissions, then that seems a lot more straightforward and easier to manage within the cluster itself.
And that's like the implementation perspective, right? This is not necessarily saying CF developers get exposed to Kubernetes RBAC or something like that. This is just
right. Yeah,
how you would implement it.
You know, I think maybe moving into some of the higher level concerns that we've had. I think that like what we built with CF has been this really fantastic and extremely reliable system at providing this end-to-end hosting environment for application workloads and the developer workflows around them. But like, you know, time and time again, we see these expressions that there's kind of, you know, it's all or nothing. There's no way to pick and choose pieces of that functionality or to make that a more permeable barrier when it's appropriate, even if that's not appropriate for most users. And, you know, I think the details of that are the thing that we do need to work out. But, you know, hearing examples of like, oh, you know, sure, if it, back when it was CF for VMs, there's you know, an easier trade-off to understand and to manage. But now that we have these more intermediate representations of application workloads as Kubernetes resources, I think we've all been feeling a lot more pressure to be able to say like, yeah, you know, I'd love a CF expression of this workload in terms of Kubernetes constructs, but, you know, I might need to break outside of that box a little bit. You know, maybe I need to be able to have a different system for generating container images that's easier and that fits in more naturally. Or maybe I want to take a look at the workload definition that CF produced in terms of Kubernetes resources. But hey, what if I just want to grab that and try tweaking it even outside of CF? Or what if I need to detach that thing and manage it outside of CF? So again, like these are things that they do violate that developer encapsulation. But if the alternative is to say like, well, you know, it's all or nothing for CF, then I think more and more we find ourselves on the losing end of that battle when we think it actually is the right choice for a lot of users.
Mm-hmm. Yeah, agree.
So I think maybe getting back to like, well, what, you know, we still feel that tension around like, we think that we know what's going to actually be most productive for a lot of organizations and a lot of developers. How do we make it more flexible for platform operators, which is, I think includes a lot of ourselves, to allow more nuanced access policy around these resources that allows us to say, you know, most of the time, yeah, it is locked down to the point where developers are going to only see the high level abstractions that they need to do their jobs efficiently. And the rest of the system can get out of the way and enable them. But when they do need to break through to those lower levels of abstraction or to understand something that's going on, or even to interact with other workloads in a Kubernetes environment, because that's not going away. You know, what are the most important things that we need to enable, or how do we grant them the access to do those things in a limited way?
Bernd, would you mind scrolling up just a little bit respect to the proposals I've made in terms of yeah, those abstractions that can be yeah, again a bit more, I think.
Oh, it's in your comments, you mean?
Yes, yeah.
Okay, then
Yes, so this comment.
use a different strategy to try and make them visible. I think that's your topmost comment for that section, if I'm not mistaken.
Yeah, a little down, yeah, there was a 1, 2, 3 numbered so that we can reason about.
Is it this one? 1, 2?
No, a little down.
Further down. Oh, here we go.
Yes. Service discovery, Kubernetes labels and annotation to discover ingress networks and points. Yeah, there was the marketplace aspect, so that can I recall this?
Over here.
Yeah, the marketplace service broker. Yes, to look up third-party workloads. So that would still be a service broker, but can use maybe labels and annotations to so that an app in Cloud Foundry can look up existing services in the same cluster. So discovery in both sides. I was thinking that maybe discovery would be one specific element that could have some value for developers to get more details and to integrate better with Kubernetes. I'm not wording it very nice today, sorry.
Yeah, so I think for the service broker, I've seen like a couple of implementations that actually already do that. I'm not sure that like having the service broker API in place kind of enables you to do these types of lookups behind the scenes somehow, right? Whereas I would say your example 1.1 here definitely is something where, like, if we say, like we have specific labels and annotations on the Kubernetes side, then it's almost as if we would define a certain API that kind of is guaranteed to exist and then continue to exist even if updates are happening.
Yeah, I think the idea of having a more regular and potentially stable set of identifiers for the workload as represented on the Kubernetes infrastructure, so that it could better interoperate with the kind of selector-based philosophy within the cluster. Like that definitely makes a lot of sense to me in terms of enabling some of the interaction patterns that I think we'd want to see in Kubernetes. I mean, maybe it's good even to tie that back to some specifics. Like I could envision, maybe that's even number 2 in your list, Guillaume, being able to say like, what if you wanted to just run the workload on the cluster using the CF app abstractions, but you wanted to use your existing ingress controller to route traffic to it. Like you didn't want to deal with whatever the CF system was going to bundle in and CF routing. What kind of metadata would we need to ensure that CF could provide on those workload units so that they could be connected adequately to, whether that's a K8s service or a K8s ingress object, or the K8s gateway APIs are kind of gelling and coming into place. So I think that one, I feel like that has come up in a few different venues already as one of these decouplings that we could be arranging with the system more fully integrated on top of Kubernetes.
Great, thanks. And maybe number 3 was to relate back to Heroku and 12-factor apps, which was meant to have no persistence and to have a backing service sending persistence. I'm wondering whether now there is use cases such as there is machine learning process running somewhere, which creates models that needs to be consumed by front ends. And those front ends are suited to be running within Cloud Foundry, but the backing service, such as S3 or streaming or database, is a bit heavyweight, and they would just want to map maybe a read-only persistent volume. So this is the extension of the current volume bounds, open service broker volume bounds binding, that could maybe enable some of those use cases.
Oh yeah, so Guillaume, you're saying like right now we have the kind of the read-write file system volume service in CF today with kind of NFS semantics around it, and you're bringing up the idea of instead exposing like a read-only file system interface to some workloads to like allow them to interact with a set of data more efficiently than kind of doing that directly over network calls.
Yes, potentially to be able to reuse a persistent volume which is written by some other processes, some other workloads. And yeah, maybe it gets tricky because of placement and all the subtle details that seems easy at first, but gets complex. So I'm not sure about this one.
Yeah, no, I think that is really interesting. And did you say that, like, have you seen that pattern be of interest for, was it machine learning workloads?
Yes, I recall an SAP talk we had on Terraform, where the SAP folks they were using Kubernetes for getting the machine learning models being built, and they were needing things like kubeflow and GPUs and low-level controls to be able to learn to make those machine learning models created. but the consumption part and the API exposition, they didn't need the full complexity of Kubernetes. So just getting those files and to load them in a Python library and serve them using a REST API would just be sufficient. And so maybe the boundary would be this volume service, which makes a somewhat clean interface, could be a clean interface at first sight. Might be more complex than I think, but
right. So that could even be a new type of volume service that's relatively easy to implement on top of K8s, but still fits within the parameters of the kind of existing volume service definition.
And by volume service, you mean the a Cloud Foundry service broker with the volume bindings, or do you mean the Kubernetes persistent volume providers?
I was thinking of the Cloud Foundry abstraction that we have today around, having that kind of logically bound to an app workload. I expect underneath then the broker would end up interacting with the Kubernetes resources fairly directly. I suppose that would have to flow through whatever is defining the actual workload to make sure that the appropriate volumes are associated to the deployment in its pod spec template or whatever else is going to be backing that workload.
I guess
were you looking for the volume services stuff?
Yeah, I was kind of, I had some memory around a Kubernetes-based persistency service, but probably that's somewhere over in the incubator or in the Cloud Foundry community repository. I wasn't entirely sure. I guess the other remark that I wanted to make is like topics like volume services, but then also maybe some newer additions to the functionality of Cloud Foundry, like labels and so on. They always make me wonder if like we would have chosen like to actually implement that type of functionality inside Cloud Foundry, or if Cloud Foundry would be running on top of Kubernetes, we would have just said, no, this is kind of outside the scope of what we built Cloud Foundry for. So previously, obviously, you had to kind of compete a little bit with Kubernetes itself. Now, to your example, Guillaume, with like machine learning workloads, I would still say that at least if we would kind of one-to-one implement today's Cloud Foundry model of like deriving CPU cycles from the RAM that you associate to an application, I think that's somewhat geared to less CPU intensive applications and more IO bound applications. And then obviously the question is, do you enhance that model? Do you make it more generic to allow also CPU heavy workloads to actually run, quote unquote, inside Cloud Foundry? Or would you then rather say, no, this is something that should kind of run next to Cloud Foundry? And if you have then, for example, a REST API, this would still be a service that you could deploy inside a Cloud Foundry on Kubernetes, and that could interact with those machine learning models just running side by side. So just a thought. But obviously we also have folks using persistency services, so there's also the compatibility angle.
Yeah, maybe it relates to the 80-20. The 80% should be made easy, and the 20% be made possible. And make possible could be you get access to the full Kubernetes API with all the complexity because you need it, so you can afford the ramp up. But the 80% that don't need that, they don't need to be exposed to this complexity, and they can keep the productive Cloud Foundry abstractions. So I was trying to find what could be contract to enable stable contracting time, such as discoverability, routing, maybe kind of persistence that allow both personas to work together without disclosing the full details of Foundry that needs to evolve again if we expose pods and the internal details. This will change potentially in every release. So we will break people that have access to those details. That it will break their work.
I think what you are saying is what we have defined here is rather like implementation APIs, and I think you were asking about like additional APIs that allow you to access kind of underlying Kubernetes implementation details, so to speak, to be able to more directly interact with these. That's a good point. I think I'm not sure who was it, but somebody kind of asked about like what is the Cloud Foundry API anyways, right? That was one of the comments that came in recently. And that was more referring to like the existing Cloud Foundry API, but I think then on top of that, if we say there is options for people using Cloud Foundry to see through some of the abstraction, yeah, those APIs will also need to be defined.
Yes, for example, the APIs we are talking about is the environment variables that applications are exposed to, the DNS discovery that allows to use DNS endpoint to discover and to route in the internal network control plane. So that's and yeah, that's the two main APIs I know about. In Cloud Foundry runtime APIs for applications, and then obviously the build packs to some extent. The build packs have their own contract as well. And yeah, maybe the idea is to extend a bit this contract to cover the part of Kubernetes that needs to interact with in a stable way without disclosing too much details.
Yeah, makes definitely sense. Okay. So
I think Kieran from the Irene team had asked about like,
okay.
is the, you know, is that even developer API surface area documented anywhere? And I think we've collectively realized over the many years that, you know, it isn't, other than just being, you know, the behavior of the current system for the most part.
GitHub.com/cloudfoundry as well.
It is on docs. Well, it is on docs.cloudfoundry.com. The variables and internet networking that they are documented.
I mean, yeah, there's documentation for, say, the Cloud Controller API. But I think a lot of the intent, it's certainly not all consolidated in one place, and many of the behavioral nuances or those interfaces inside of the build or the runtime environment are not very explicitly documented.
Yep.
There's certainly no place that's just a pure spec that says here's what all the interfaces are.
Yeah.
You're talking about like Diego interfaces to extend the system, or are you talking about the environment variables that are surfaced to applications at runtime?
Yeah, the latter. You know, what's the totality of the, not just environment variable, but you know, even file system interface. Yeah, again, you're right, Guillaume. Some of that is documented in terms of the environment variables.
Also very subtle things like how does cell draining work if you update like Cloud Foundry itself, like what happens first, what happens next. I mean, also that is specified somewhere in the documentation, but not like in a very testable way, so to speak. I'm not sure if there's any good.
Yeah, and I think there isn't necessarily a specification that says like, well, this is the behavior that we would want from the system, regardless of how it's implemented, in terms of the lifecycle expectations under normal operation for workloads when the system is being updated. That may be specified somewhere else, even in terms of describing the behavior, but I don't think that, there's certainly no like certification or compliance statement around, saying your CF system should or must do X when it's updating worker nodes.
Okay, good. Thanks.
Then the next one is also on the Kubernetes API. I think that's asking the inverse question, right? Like, how do you prevent Kubernetes from shining through for the people that don't want to see it, right?
Yes.
Okay, and I think your comment referred to the namespace example where I made a remark that like at least this particular example of like hierarchical namespaces, if they are becoming a reality in Kubernetes, is more like an implementation detail. It's not so much something that would be visible one-to-one to people using the system itself. And then like the kind of duality of the role of developers using ACF on Kubernetes, like the existing ones that are probably happy with what exists today and don't want to have additional abstraction. And then the people that I think also Eric was referring to, looking at the topic from a Kubernetes background and like wanting to have those interactions between Cloud Foundry based workloads and other workloads, and how to kind of strike the balance to actually be attractive for both groups. Okay, then or to your comment around the examples. Okay, so I think we've covered this one then. But by the way, the article that Eric has pasted here in the comments is also very worthwhile read. I think as he points out.
I would recommend having to bat through several layers of cookie information and popovers is probably worth it to get to the content underneath it. as annoying and initially deterring it may be.
Okay, then the next one is on the KP-v3 entities as CRDs. And I made a comment, and Giuseppe is on the call as well, that at least I know that the Irene team is working on like wrapping their entities into CRDs. So it's not like directly the cloud controller entities, but kind of the thing that gets generated from the cloud controller entities, so to speak. I'm sure Giuseppe is there like any findings from that effort or feedback that you can share?
Yeah, I mean, we started pretty much trying to replicate the Diego API as much as we could, and then we kind of had to replace some of the features of that API to be a bit more Kubernetes native, for example, getting rid of all the callback-based workflows, replace them with things that look a little bit more like events, or things that can be just watched in the spirit of like the way Kubernetes things are done. Other than that, that is pretty much it. And this would be the workloads orchestration API, like in that list of APIs that we would have to solidify, like as like interfaces that can be implemented by different backends. I think the Irene one would be could be a starting point for that API. Given this opportunity, it's an opportunity. Given we are changing, we are basically rewriting the Irene API, right? We're porting it from REST to LRPs, to CRDs. It is an opportunity if we want to change stuff to do it, because while that API is still in beta, it's still completely experimental and it hasn't been released. So like we should try to work from the two ends of the interface to see which one, like what makes us happy as a good interface that we can then stabilize, and it really could be an implementation of that. Yeah.
And that would then mean that both the cloud controller would generate the CRDs that then Irene defines and consumes, as well as there could be others kind of generating the same custom resources via completely different means, right? Eventually. Yeah,
the idea would be, yeah, at that point, Irene, that's already the case. Like Irene has an API that can be consumed by anyone. Although in practice, it's only CC consuming it. But maybe it could be a case of Irene not being the only thing that CC can consume if we decide that that API is stable and standard, and we document it, etc. And there's an opportunity for other players to come in and say, we want, I don't know, to schedule workloads somewhere else or in a different way. We can just implement the API, whatever it is. And same for all the other 5 remaining things listed there.
And just maybe toward the suggestion I was making, I understand that the Irene API is more for contributors that would swap in potentially Cloud Controller. They are not designed to be surfaced to Cloud Foundry operators or to Cloud Foundry developers.
No, definitely not supposed to be surfaced to users, because it's quite low level, right? Like just like the Diego API. I think at the moment, if you really want, you can try to hit Diego directly, but you have to pass in your request would not be very ergonomic, right? You would already need a built image, and you would need to know a bunch of things. You would need to know how many processes you want, and that's all work that the CC does for you when you make a CC request, which is the request that is supposed to be made by a human. So yeah, definitely not designed for human consumption, I'd say.
And so maybe the challenge is that we do need all the feature set that CC does and maintains well. We do need to maintain the CLI and the Cloud Foundry experience because of the population associated are happy with that. At the same time, we need Kubernetes users to be using native custom resource with the same level of abstraction for application developers.
Yeah, so those would be CRDs defined by CC or whatever component we decide would replace CC. So CC has concepts like an app, a manifest, I don't know, roots, whatever. Like Irene has concepts that are one layer below. So yeah, like translating the CAPI API to CRDs I think is a separate effort from the Irene one. Although of course having Irene expose CRDs, I think it's going to make things easier, because given we are switching from an imperative to a declarative way of working, having declarative end-to-end is much easier. When you have to at some point turn imperative into declarative or the other way around, that's when like it becomes a little bit more annoying, which is what Irene has been doing so far. Like we translate the Cloud Foundry imperative requests to declarative requests to Kubernetes, and that's been a source of a bit of a mismatch, right? So going declarative end-to-end, I think, is going to make things a lot easier.
And we see many community efforts that dynamically generate those custom resources. So from the cross-plane Kubernetes community, we see many cloud providers such as AWS, GCP, Azure, that automatically generate the CSDs from their open APIs. For example, they have an open API for their REST API, which CC doesn't have. CC has its own format. Basically, they take what exists and they wrap it as CRDs. And so I was thinking, is there a cheap way to do that for CC API? Maybe one avenue could be maybe as a POC, maybe just to get feedback from community. The Terraform provider for Cloud Foundry is just doing that. It's wrapping CC API into a direct declarative way. If you recall, there is if you go to documentation, you have documentation on top right, and you can browse to it about. Yes, you on top right you have the HTML, but yes, yeah, definition of the provider, and then you basically you have Cloud Foundry application, Cloud Service instance, service binding. So that's for application developers, and we have org space, build packs. So the full isolation segments, private domains, quotas, and all that. So all of this is already maintained by the community, and there is effort in the cross-plane community to take a Terraform provider and to automatically generate a CRD out of that. So maybe that could be, that was the suggestion I was making, could be a way to, in a cheap way, to generate CRDs that exactly match CC API without much effort. It still relies on the Terraform provider Cloud Foundry to be maintained. And I think there is planned effort to migrate from V2, CatPV2 to CatPV3. But yeah, just wanted to point out this alternative.
Yeah, I guess it's a bit of a dangerous game to play, given I think it's the same for Terraform. Like there is some state that Terraform has or CRDs have, right? CRDs are saved into etcd, right? And then so you create a CRD, you create a resource which is stored into etcd, and then there is a watcher that picks it up and then makes a REST request to Capi, which puts it in its own Postgres. So you constantly have two pieces of state that need to be constantly synchronized. So it can work, but there is always the risk that those two get out of sync, versus deciding that the source of truth is the CRDs. And then you can have a REST API in front of the CRDs to manipulate the CRDs, because that's what Kubernetes has as well, right? Like, I don't know if it can be called REST, but effectively it's an HTTP API, the one you use to create the CRDs, etc., and watch them. But I think the other way around, given like if you keep the old database, then you have state in front of procedure calls in front of state, while you can get rid of one of the two states if you use the CRDs as the source of truth. Of course, it's a much more expensive change. So I see your point about this being very cheap versus like, because getting rid of the whole database in Cloud Controller, etc., would be quite expensive. But like akin to a rewrite, pretty much.
And just to add on that, like we do this in a couple places already where we have that two sources of state, like one of them being routes, where because we have it in the database and in Kubernetes etcd, we have to have syncers on both sides. That like ends up being pretty expensive and like kind of takes away from like the Kubernetes native aspect, since we have this thing like looking at CCDB and just clobbering everything in Kubernetes whenever it sees a discrepancy. It gets a little wonky there.
I understand. And I wonder also,
Tim, that's the case for the existing like route support in like CF fricates today.
Yeah, because like we did, like at the start, a lot of these issues were like theoretical, and then we did actually see discrepancies where people would make imperative changes through the CF APIs and they wouldn't be reflected in the route on Kubernetes because of just like network hiccups or weird ordering things. So we had to develop a syncer on the Cloud Controller side to just on a loop, like classic, like Diego style, push data and clobber everything in Kubernetes to reconcile that.
Yeah, that effectively becomes a controller, right? Which is constantly checking if the reality matches etcd and the other way around. yeah, then you have two, right? You have one in the back, one at the front. It's a bit of a mess.
Yeah, and I imagine we'd have to do something like that for every resource. So like for routes alone, that ended up being pretty expensive. But to do everything, especially ones that like routes were nice because they were isolated in a single table. But for a lot of other API resources on Cloud Controller, it's stuff that's split across tables in the database. And then like syncing that gets, I know this is implementation-y, that gets even more difficult though.
Yes, and maybe it's interesting to raise the fact that Cloud Controller maintains kind of transactional consistency to the imperative request that it receives, and splitting that into independent resources. Sometimes there is relationships between those resources. And so getting that into a declarative way where there is only the open API input validation, which is possible, but the more consistency check is always asynchronous, then I think it makes it challenging to keep it simple. I think then it needs to be very fine-grained for each resource to ensure referential integrity review others and stuff like that, which comes with the complexity that we see in Kubernetes. So maybe getting a fully native Cloud Foundry native CRDs with etcd being the only source of truth, and getting rid of Cloud Controller input validation logic would be as well, I think, quite challenging in terms of user experience.
The referential integrity is actually a good point. I'm not sure if, let's say, the Kubernetes community has developed strategies to kind of achieve that, or like it's just accepted that things are not like transactionally safe, so to speak.
Yeah, in general, I think it's just you design differently because it's not a relational data store. So like you can't just have different resources with relationships that you know will be kept consistent, just like you would in a. On the other hand, it's not as bidimensional, like it's not as restrictive in terms of what you can put in one table or in one type, right? So usually things that change together, you put them in one resource definition. Hopefully you can do it. Like it's not always so easy. And then there is this concept of an ownership, like a resource can own another thing so that they can be deleted together and stuff like that, or they can be notified when things change, but that's pretty much it. So you have to think you're going from Postgres to maybe, I don't know, Mongo, or even worse than that. You design around the lack of guarantees, I guess, because you can do atomic changes. There is a way to patch objects, and so that you can make a request, and you know that if the resource you're changing has changed while you were trying to change it, then the request will fail. So you do have some atomicity, but like you don't have the tool set that you have on a relational database. Definitely not even close.
Yeah, I wonder if it's worthwhile identifying maybe what the biggest sources of concern are there that might even be informative in terms of like the system design we would want around that, or running a smaller in scope spike than trying to do that for all of CC. I don't know if Tim or Giuseppe or anyone else who's been digging into some of those details over the past year or so has anything off the top of their heads. But if not, that could be something to pursue outside of this.
Yeah, I mean, the Irini data model is very, very, very simple. So we didn't really see the problem.
Yeah.
I guess CC has a big database. I don't know. It's probably where the problems would arise.
Yeah, we have a lot of like theoretical thoughts on it. I believe in our backlog, we have a spike to actually like try and implement something that looks like the V3 apps controller that does involve some relationships across resources and see what that might look like, but we haven't worked on it yet.
Yeah, it makes sense. Also, maybe interesting to ask, like, would it be okay even to relax some of those that they could be dangling or eventually consistent? And what would we do about that? Maybe to, I think there's at this point a lot of precedent from the Kubernetes community itself in terms of like, you have all these resources that aren't actually coherent. What does the system do, or what do end users do to reconcile that?
Maybe looking at the time, let's try and see if we can touch upon the remaining 2 comments. Guillaume, you had one around, what is it? Changing like via the Cloud Foundry API as well as the Kubernetes API simultaneously. Was that like the main point here?
Yes, I think it's kind of, we already covered that.
Okay.
I think it's duplicate.
Mm-hmm.
The fact that if we give developers access to the inside the engine and they can make some mutations, then the Cloud Foundry automation is broke. So it's about giving stable APIs without too much access that we cannot guarantee backward compatibility.
Okay, makes sense. There was another comment by Pierre talking about overlap with things like Knative. I was kind of making a comment around like Knative might obviously be one kind of alternative implementation for workload orchestration, right? So that was essentially one thought why we said workload orchestration might deserve an API that could be implemented differently. Maybe not even necessarily in terms of a containerized workload, but yeah, I guess Knative is kind of very close to like being a good alternative implementation for this particular API.
Yeah, I didn't quite understand Pierre's comment about build packs, because I mean, at least in the current incarnation of Knative, it's effectively absolved itself of any of that.
That's true. Yeah, the domain piece is out, right? Yeah.
Yeah, it's just like, you got an image somewhere. Congratulations, we'll help you run it.
Right. Yeah. Okay, and then we have comments from Giuseppe.
Mostly about the scope of the workload orchestration API regarding multi-cluster. So just thinking about how this would look like, we've talked about basically leveraging isolation segments to achieve multi-cluster. And I think at the moment, the Diego API takes care of it. So you just tell Diego, here's an LLP, put it in this segmentation. This is the segmentation segment tag or something. And Diego takes care of keeping a distinction between segments. So we could do that in Irini, but given the API is declarative, and we still need, I think we would still need resources for each process running. Then we would have to duplicate, like every process would need a resource on the control plane and a resource on the actual affected, on the actual, like on the cluster that is we want to deploy to, and that felt a little bit too much compared to maybe teaching the cloud controller upstream to tell, like, okay, which cluster does this belong to, and just create a resource there, which means yes, the cloud controller needs to keep track of which cluster belongs to which isolation segment instead of 100% delegating to Diego. But it saves us a little bit of this, like a little bit of, I don't know, boilerplate, almost like extra stuff that is just needed, but not necessarily. Or because alternatively, we put ourselves in this situation. I don't even know if it's doable, but like we could also think of just creating resources only on the control plane. And then you have a controller on the control plane that needs to watch both the resources on the same cluster, but also it needs to watch the deployments or stateful sets that it creates on the remote cluster. And I don't know how that will work. I'm pretty sure it can work, but like it's two different clusters with two different authentications. I've never seen a controller that is able to watch resources on two clusters at the same time. And also, so I don't know if that is possible. And also, I don't know if you can do this with two separate controllers. I think maybe you can actually, I don't know, but like it will be a bit weird. So that's why I think like if we could do this up front, it would make things a little bit simpler, given how Kubernetes works, even if it's a bit different than what Diego does at the moment. So I don't know. Maybe we can find a way. I don't know.
Yeah, I think that's. Oh, go ahead.
Go ahead, Aaron. Yeah, actually, I was about to say that like the other implementation would have the elegance of not requiring Irene to be deployed in each and every workload cluster, but kind of being deployed centrally. But obviously, you're right. Like the implementation of that would be way more complex than just kind of having that run in one cluster, watching one CRD, and kind of generating a bunch of others in the same cluster.
Yeah, I think it's kind of idiomatic for Kubernetes controllers to just watch stuff in their own cluster and even in their own namespace. Like just by leveraging this convention, for example, Irene doesn't need to care too much about namespaces, etc. You just deploy Irene and it just watches. You tell it which namespace to watch, it just watches that namespace, and that's it. So yeah, things will get a lot more complicated if you have all these layers of hierarchy where you have multiple clusters with multiple namespaces, and it kind of explodes.
Yeah, one thing I was just
gone.
Oh, go ahead. Sorry. Yeah. Oh, well, I was just thinking like this is maybe kind of interesting to intersect with the discussion we just had about representing the higher level CF resources also as CRDs. I mean, would we still end up in a pattern where we need some sort of like we've now entered the Kubernetes form land of resources, and so probably the path of least resistance in terms of implementation would be we have some sort of controller that's understands what we think of as the CC entities today, like apps or processes or whatever, with the associated set of either context or explicit selectors on them that kind of give hints about where they should actually be realized, if we're talking about a multi-cluster topology. And then do we still have some sort of controller that is acting on those resources, and maybe it's driving those Irene or Irene-like CRDs in either the same cluster or other clusters simultaneously.
Yeah, so yeah, the problem I just described, I mean, I'm thinking of we're bypassing it because I'm looking at it just from the Irene perspective, but it would actually be bubbled up to whoever creates the Irene resources at that point. So like, for example, I push an app, this results in one app resource, which maybe is associated to an LRP resources. But if you want these LRPs to be on a specific cluster, then you have to create these LRPs on that cluster, and then you need to, from the control plane, you need to watch them. Because again, you need this double, like you need to watch in both directions. Like when the LRPs change, you need to reconcile them. And when the app changes, you also need to reconcile the associated LRPs. So actually, we probably can't get away from this, and this is because like Kubernetes was never supposed to be used like this, like with many clusters like at the same time, right? Like controllers are just designed, the scope of a controller is always a cluster. So maybe there's no running away from that.
Yeah.
I've seen some experiments of people basically replicating the controller runtime, which is a framework that is used to create controllers for multi-cluster. So just to kind of, you use it like a normal controller runtime, but it's multi-cluster. I've seen like a little open source project built by someone. It's kind of abandoned, but it could be an interesting proof of concept, because in the end, all this watching is not magic. It's just HTTP calls that are left open so that the server can send events back. So it's not impossible. Technically, like it might need that we need to rebuild some of those core components that people just tend to just reuse because it's a framework. But it's definitely not impossible technically, because HTTP is HTTP. So it should be able to work in cluster just like across clusters. There's no reason it shouldn't. Interesting. I think the one I have seen was not this, but could be another.
Yeah, so Crossplane is defining CRDs with a kind of a composition mechanism. And in this project, they have an agent so that one client Kubernetes clusters is able to define custom resource locally that gets basically execute on a central cluster. And the way it works is that they have an agent on the client Kubernetes clusters that calls home to the central cluster, fetch all CRDs to execute them locally, well, to get their definition. And then when a user asks for a resource on the client cluster, it creates a resource remotely in the central cluster and gets the response back. So maybe a similar pattern could work in the sense that maybe Erini could be defining resources that gets replicated on two different clusters, kind of messaging, if you wish. There is a design doc on this page that tells a little more how they get.
This one I am talking about. It's a bit abandoned, but it looks pretty much exactly like the runtime controller. So again, it's doable. It's just there's a risk we have to reinvent the wheel on things that are a bit tricky, like caches, like stuff like that. Yeah, doing this in CC, I think, would still save us from one resource creation. So per process. So that's not bad. So basically, otherwise, every LRP on every cluster would have a correspondent LRP on the control plane cluster. So there will be a bit of a proliferation. But yeah, the multi-cluster the problem of having controllers that cross the boundaries of a cluster, I think we can't. We'll have to face something one way or the other.
Yes, I have to cut the conversation a little bit short because we are already slightly over time. I would say thank you very much for the feedback and the discussion for now. We'll take another pass, I guess, on the comments that are in there, and then take it from there.
Yeah, and I think I'd really encourage everyone to think about, like, we've been identifying this perspective on what we think CF Uncates can be realized as, and so I'd really like people to provide input on where they think whether that's a continuation of CF Uncates or whether we need some more dramatic changes there, like where you would actually see yourselves being able to put some of this into use, or what blockers you would have in order to actually start using a system like this. Because we've had that with CF Uncates right now. And we have a few examples of people using it, but a lot of people have been holding back for various reasons. And we want to get past some of those barriers and get everyone aligned on a common picture here. So I think getting a clear picture of some of those requirements and goals that we would all have in mind, or things that we have feedback, maybe from other people who aren't in these sessions, but that we view as important stakeholders in the community. That'd be really beneficial as we start talking more about some of the details of how we're actually going to implement this and carry it forward.
Okay, thanks, Eric. So then, thank you very much, everybody. Talk to you next time. Bye.
Bye, have a good day. Thank you.